We're going to find the volume of a solid of revolution obtained by rotating the region bounded by the graphs of y equal to 2x squared minus x cubed and the x-axis about the line x equals minus 4. So we're going to sketch this region first. Let's find out the x-intercepts for y equals 2x squared minus x cubed. We just take 2x squared minus x cubed, set that equal to 0, factor out x squared, so x squared times 2 minus x equals 0. X is either 0 or 2. Now pick a value between 0 and 2. Easy one is x equals 1. Plug it into this function. We see that y will be 2 minus 1, which is 1. That means whenever x is between 0 and 2, y is positive, so it's always above the x-axis. This is what the graph roughly looks like. It looks something like this between 0 and 2. So that's 2 and that's 0. Now bring in the axis of rotation. The axis of rotation is this line x equals minus 4. We will not be able to solve this problem by using the method of washers because it will be very difficult, if not impossible, for most Calculus 1 students to solve this function 2x squared minus x cubed for x in terms of y. So the only option we have is to use the shell method, and which is not going to be difficult at all. To use it, pick any x between 0 and 2 in this region. So here's a typical x, and then look at this vertical slice of the area. As this slice rotates about this line, it's going to end up somewhere over here 180 degrees into the rotation, and then a full 360 degree rotation is going to generate this cylindrical shell. The problem comes down to expressing the area of this shell, the surface area of this shell, as a function of x. So first let's review the formula for the surface area of a cylindrical shell. I'm going to draw a typical shell right here. It's just a cylinder without the top and the bottom. It has a radius, let's call it r, and a height h. I want to find a formula for the surface area of this, just the area around the cylinder, not the top and the bottom. So we're going to cut it along the height and then unfold it. When we do that, it's going to end up as a rectangle. The width is just the height of the cylinder h, and the length is what used to be the base right here. So we unfold this. It's just the circumference of the circle with the radius r. That's 2 pi r, and therefore the area is equal to 2 pi r h. Now here we want to find the integral from 0 to 2, and we'll have 2 pi in front. We just need the r and the h as functions of x. Now notice the axis of rotation is the line x equals minus 4. There it is right here. That's the center of our circle. So from this point to the y-axis, that's 4 units. And then over here where our x is, that's 4 plus x. That's our radius, is 4 plus x. That's r. And the height is right here as a function of x. The height is 2x squared minus x cubed. And that's h. You can see that's 2 pi rh. We do it for every one of these slices for x between 0 and 2. And the rest of the problem is just integrating this integral, which is not very difficult at all. If we use the washer method, it would be almost impossible to solve it. So this is 2 pi times the integral from 0 to 2. We have 8x squared minus 4x cubed plus 2x cubed minus x to the 4th. So let's simplify this. And this is 2 pi times the integral from 0 to 2. We have 8x squared and then minus 4x cubed plus 2x cubed minus 2x cubed minus x to the 4th. It's a very easy integral to evaluate. So let's go ahead and finish this. This is 2 pi times 8 over 3 times x cubed minus 2 over 4 x to the 4th minus 1 over 5 x to the 5th evaluated from 0 to 2. Plugging in 0 gives us 0, so the answer is 2 pi times 2 cubed is 8 times 8, 64 thirds. 2 to the 4th is 16. 16 divided by 4 is 4 times 2, that's 8. So 64 thirds minus 8 minus 32 over 5. So the common denominator is going to be 15. This is 2 pi times, write down 15 for the common denominator. We multiply 64 thirds by 5 over 5. That's 320 over 15. 8 times 15 is 120, so minus 120. 32, we multiply 32 fifths by 3 over 3, so that's minus 96. And so the final answer is equal to 2 pi times 320 minus 120 is 200. 200 minus 96 is 104. So this is 104 divided by 15. We multiply it by 2. We have answer 208 pi divided by 15. It's much easier by far to use the shell method than the washer